Yes, my students, today a very important topic, that is effect of electric current. Before starting the main topic, we are going to clear some basic concept of the electric current. Okay? Now see here, the first I am going to write the definition. Here, what is an electric current? Electric current. Definition of electric current. As you know that the electric current flow due to the flow of electron in a conductor. Okay? In conductor, the electricity flow due to the electron. In solution, it is due to the ions. Okay? Now see, it means that it is the flow of charges. Okay? Then its definition is like it is rate of flow of charges. Rate means with respect to time. Means flow of charges with respect to time is called electric current. Therefore, as per definition, its formula is I is equal to Q upon T, where Q are the charges. Okay? And electric current is represented by I and T for the time. Okay? I am going to write its unit of electric current is ampere. It is measured in ampere. Okay. Now after this, the second definition, here I am going to write the second definition, that is potential difference. What is potential difference? Now see, first what is potential? Potential is the level of charge at a point. And when there is a difference in the level of charge, then only current flow, or you can say for the flow of current, electric current, there must be potential difference between 2 points. If there is no potential difference, current will not flow. You have seen that if you are going to connect the two terminals of a conductor with the same positive charge of the cell, okay, positive terminal of the cell, you have seen that current is not flowing, because they are at the same level. Okay. Therefore, for the flow of current, potential difference is necessary, or you can say the potential difference work as a force to move the charge from one point to another point. And as it moves a charge from one point to another point, there is some work done. Okay, therefore The potential difference definition is it is the amount of work done to bring a unit positive charge from one point to another point. It is the work done. It is the amount of that I am going to write here. It is the amount of work done to bring a unit positive charge from one point to another. Okay. It is the amount of work done to bring a unit positive charge from one point to another point. As per the definition, the formula here, that is potential difference represented by V is equal to W upon Q, where W is the work done, where W is the work to bring a charge Q from one point to another point. Unit of potential difference here, unit of PD I am writing potential difference is volt. Okay, unit of potential difference PD is volt. Okay, it is measured in volt. The next important definition that you have learned in the ninth standard, that is Ohm's law. Okay. That is Ohm's law. Now see here, Ohm's law, it relates between the voltage, current and or resistance of a conductor. Means it relates the voltage, potential difference, electric current and resistance of the conductor. I am going to tell you what is the resistance later on. Okay? Now, here Ohm's law, according to this law, if, here I am writing, if the physical condition remains constant, then the potential difference applied on 2 units of conductor is directly proportional to the current flowing if the physical condition remains constant, the potential difference applied on two units of conductor is directly proportional to the current flowing. Okay? As per the definition here, V is directly proportional to R. Now see, what are the physical conditions? Physical condition means the length of the wire, area of cross section of the wire, means thickness of the wire you can say, temperature and pressure. These are the physical conditions. If these physical conditions will remain constant, then the potential difference applied is directly proportional to I, means if potential difference will increase, the current will increase, and this is equal to, here it is R. V is equal to IR, where R is the resistance of the conductor. Okay, this is resistance of the conductor, and it is fixed for a particular material and particular, as I told you, this is fixed for the particular conductor or material. We can write here V upon I is equal to R. This shows that if the physical condition remain constant, then the ratio of the potential difference applied to the current flowing from the conductor is a constant, that is R, or the resistance, and the unit of resistance R is ohm. R in bracket like this. Symbol of ohm is like this. Okay. Unit of resistance R is ohm, or this symbol is also called ohm. This is the. Now see, these three definitions are the basic definitions of the electric current. You have learned this in the 9th standard. Now the main topic is your Joules law that we are going to do. The next topic is Joules law. I am writing Joules law. Now see here. First I want to tell you what is Joules law. Okay. Joules law, it tells about the relation between the heat generated in the resistance H and the current flowing through the resistance I, resistance of the conductor, and time t. Now see, I would like to tell you that this Joules law relates the heat generated with the current flow, resistance of the conductor, and the time period for which the current is flowing. Okay? Now see here, I am going to explain it. See, here this is the circuit diagram. Here if you will see that this is plus sign, this is minus sign, I current is flowing through it. Okay? I current is flowing through it. Here this is the R is the resistance, R is the resistance. Okay, this is the resistance. Now see here, if the I current is flowing through it, it means the flow of current means that is flow of charges. Suppose Q charges are flowing from point A to B. Okay, then the work will be done to bring Q charge from point A to B. Okay, and that work done will be equal to the potential difference between these 2 points, that is VAB. Potential difference VAB shows that this is between the point A and B. Okay. Now see here in this circuit diagram, A here, A means ammeter is connected here in series with the resistance to measure the current. Okay. And here this is voltmeter, which is always connected in parallel to the resistance to measure the potential difference. Here this is the potential difference between point A and B. Okay. Now see here I am going to draw this, complete this diagram here. Just I am going to complete it. Okay. Now after this, see here. As I told you, the circuit diagram is like this. Current is flowing from positive. Now see here, the same figure here. The current is flowing from positive terminal to negative terminal. Now see here, though the current is flowing due to the flow of electron, that is from negative to positive, but it is the conventional method to show in the diagram that always current flow from positive terminal to negative terminal. Whenever a circuit diagram is drawn, you will see that the current always shown flowing from positive terminal to negative terminal. Okay, now see here, I would like to complete it. I am going to connect here a voltmeter parallel to resistance, and this potential difference is VAB. Therefore, as I told you, the work done will be WVAB into Q. Okay? This is the work done. Okay? Now I am going to start that what is Joules law and its derivation. Now see here. First, I am writing here in points that if I current is flowing from a circuit of resistance R for time t, and V is the potential difference as shown in figure. The work done to bring Q charges from point A to B will be W is equal to Q AB, W is equal to VAB into Q. Okay, this is the work done. And the power consumption, that is electric power consumed, P is equal to work done with respect to time. Okay, therefore substituting the value, P is equal to VAB dot Q upon T. This is the value substituted from here. W is equal to VAB dot Q. Understood? Okay. Now the next here I am going to write again the same thing, that power P is equal to VAB dot Q upon T. Then as per the Ohm's law, that is V is equal to IR. Here instead of V it is VAB. Okay, this is IR, and I, as I told you by the definition of current, I is equal to Q upon T. Therefore this term is equal to I and this term is equal to IR. Therefore P is equal to I R P is equal to I square R. This is the power consumed while the charge Q is flowing from A to B. Now the heat generated, the heat heat generated H is equal to power into time for which the current flow, that is H is equal to, instead of P we will write here I square R T. This is the relation for the Joules law. Okay? This tells us that if I current is flowing from a conductor of resistance R for time t, then heat generated is directly proportional to square of the current flowing. Heat generated is directly proportional to the resistance of the conductor, and heat generated is directly proportional to the time for which the current is flowing. Okay? This is the Joules law. Here I am going to write it. If I is the current flowing from a conductor of resistance R for time t, then the heat generated H is directly proportional to the square of current flowing I, resistance of conductor R, and the time period t. This is the Joules law, and that is represented here as H is directly proportional to I square, H is directly proportional to R, resistance of the conductor, H is directly proportional to T. It means that if the current will increase, the more and more heat will generate. If the resistance of the conductor is more, the more heat will generate. And if the time period for which the current is flowing will increase, the heat will increase. Therefore, H is equal to I square RT. It can be written as H is equal to VIT, means instead of IR, V is equal to written here IR. Okay, this is the Joules law. Now the next topic we will take